Starting the alignment procedure for the Sentinel radio. Stay tuned. Good morning, YouTube. Here with you at 11:25 a.m. on a Sunday morning. Making this video. This probably won't be posted till Tuesday. The one I have already made last night, or yesterday actually, it's going to be posted Monday, so I think this will be Tuesday. Now this is going to be the first part, and I don't know how many parts there's going to be. I'm going to tell you that right off, of the alignment of the Sentinel radio. The reason being is I'm trying some different stuff here, and I want to basically see what type of setup I want to use. And I know that I've been working on the IM 5284 for this purpose, and I'm going to use it, but not in the sense that I was going to use it to begin with. Now normally when you align these radios, and I'm saying normally because I think most people use this method, you basically hook up a AC voltmeter, which is going to be in our case that heat kit, to the across the speaker terminals right here. Let me get my pointy stick. Across the speaker terminals right here, and basically measure the voltage going into the speaker, or outputted by the speaker, or whatever you want to call it. Now that's traditional method. Now there is another way of doing this, and a lot of you guys that do a lot of AM radios and any kind of radios, as a matter of fact, know that you can use the AVC voltage to do the same exact thing. The AVC voltage will increase as stations get stronger, and that's what makes the AVC work as it works, and adjust the gain on the previous station or stages. So basically what we're going to try to do this time is use the AVC voltage for our alignment. Now, alright, some of you guys that don't know how to do it, let me show you exactly what we're talking about here on this schematic. Let me move the radio over here, and we'll put the schematic up here. Now, the AVC voltage is produced basically here at the detector. It is fed to the volume control here. Now I don't know how well you're seeing it, but and if you follow this detector down here like this, you'll find this is a high value resistor, a 3.3 mega ohm resistor here. And if you follow it on down, you see a capacitor going to ground here. Now this is the AVC line right here. It's fed into the bottom of the AM loop stick, and also into the bottom of the or comes from the bottom, or fed into, whatever you want to call it. It's fed back into the grid of the previous stages to adjust the gain on those stages. In other words, it comes up through this, this is solid wire here. It may be a coil, but it is solid wire, and the DC voltage will get through. And it's fed to this stage here, which is the first IF. Well, the only IF in this radio, but so anyway, what it does is basically, as the volume, or I keep saying volume, and it's really the signal strength gets greater, the AVC, or automatic volume control, ramps up a little bit to, and it's a negative voltage. So it ramps up a little bit and puts a little bit more negative voltage on the grids of these previous stages. And when it does that, it reduces the signal, the amount of signal, to keep the volume level at a certain pace, or a certain level. So that's what the AVC does, or how it works. But anyway, you can monitor this, like I said, across this, basically across this capacitor here. Or in my case, I'm going to take the, if we looked at the radio, it's this. Let me show you. I think you can see it. Yeah, it's this antenna lead here, which is this part here, and that's the one we're going to connect our meter to there and to TASI ground. So that will give us the same thing as across. In other words, from here to ground is where we're connecting to. So that gives us the same thing, and we're going to monitor this. I'm going to do this first with just the radio hooked to the, you know, I'm not even going to, what am I trying to say? I'm not even going to do the alignment part. I'm just going to hook the radio up, and we're going to watch the voltage, see what it does. And we'll notice, I think, and I'm going to set the range to about 10 volts negative DC. And like I said, that's another thing. I wanted to use this because of the DC. I think the DC voltage is a little more accurate than the measuring the back of the, or you know, the output of the speaker. Anyway, so your goal here is to keep your AVC or your well, not your AVC, but your signal level coming out of the signal generator at the lowest possible level to keep the AVC from growing, you know, cutting itself off. You know what I mean? In other words, when it's at high, it's going to cut itself down, and it's kind of hard to monitor that way because it's constantly going back and forth. But anyway, so that's the I hope I explained that halfway decent, and if I didn't, I'm sorry. I'm not a teacher, you guys know that. But let's hook it up and see what it does, and maybe I can explain it a little bit better then. So let's hang on just a second. Let me get this hooked up. All right, now basically what I have hooked up here is the radio, as I outlined on the schematic. It is hooked up to this point right here. Let's see if you guys can see that. This point right here on the schematic across this capacitor. Now, like I say, you can see the indication on the meter. It is going up and down just a little bit, not a lot. But watch what happens when we tune this and see what happens then. Now, some of this is just static, I understand, but you can see how it goes up and down depending on what's coming into the antenna. And I do have the antenna hooked up as it's supposed to be for the alignment. So I'm just going to tune around a little bit and see what happens, hoping we can find a station maybe. Any kind of signal, now, you know, you may not hear it on the speaker as much, but any kind of signal will make that voltage go up. There's a rather strong one right there. So you can see how that works, and it does work pretty good. So far I haven't heard any signals. See where we're at on the station. Yeah, we're probably past 84. There's one right there. Very weak. So
He's making us look stupid. Who does he think he is?
Okay, there's your local station.
Opened, and out stretched the man.
So now this is independent of the volume control. You can turn it up or down, or that's one of the things you like about having this, using this voltage to adjust with, because it can be adjusted, and you can basically use it as a signal strength meter.
You've got no business here.
So
How dare you?
anyway, that's basically what I wanted to show you. Is just how well that works as the
Was never again heard in that city.
medium for adjusting the signal strength.
Pharisees.
So,
You
all right, I'm going to turn this off, and we're going to set up with the. Now, also, let me go over another thing here. Also, on the alignment instructions for the Sentinel, it is a rather convoluted set of instructions here. I'm going to flash this up on the screen so you can see, read along as I show this. Now, our first, let's go on up to the pre-alignment instructions here. Before starting alignment, check the tuning dial adjustment by tuning gang condenser until plates touch maximum capacity. Stop completely in mesh. Now that would be towards the bottom of the, I believe. I think I checked it out before, but anyway. Let's see. Where was that? Oh yeah, completely. At which point the dial needle must be exactly even with the last line on the low frequency end of the dial calibration, which it is. I've already checked that. If the dial needle does not point exactly to the last line, move to correct position. So we don't have to worry about that. It does exactly what it's supposed to do. Use an accurately calibrated test oscilloscope, and that's the RF signal generator, and some type of output measuring device, and that's the I started to say the VTVM, but it's actually the FET-VOM. Use an accurately calibrated test oscillator. Oh, I just read that. Place the loop antenna in the same position it will be with a set in the cabinet, approximately 5/8 space between the loop and the chassis, and that's, if you guys, I think I showed you that. If I didn't, that's why I've got the clamp in there. That's close enough. I mean, it's not going to matter that much. First instruction is the one we're going to concentrate, obviously, on first. So, set the receiver dial to. Basically, adjust the dial to, let's see, any point where there's no interference signal received. In other words, a quiet spot on the dial is the optimum setting for this. And why that is because we're going to be feeding a 455 kilohertz tone into the receiver, and I'm not feeding it this way. It's not going to be done that way because this is just too convoluted for my, it's done this way because it's a live chassis or a hot chassis, and I understand that. But I've always had better luck with just taking a regular loop antenna from another radio, putting it close to the loop antenna of this radio, and radiating the signal into the radio that way. I think that's closer basically to what you have with a radio receiver, because you don't generally hook up wires to different stages of the radio to get a signal in. So I think this is the best way to do it, and that's the way we're going to do it on this radio. So let me hook that up and show you, or bring you back, and I'll show you what we got.